Everybody, welcome again to Flink Forward. The real time is the future. Along my side, we have Ashish. This is Swaroop. We will be talking about how we can harness the streaming of data for the usage of in AI applications using Flink. If you can go to the next slide, please. We'll be very short and simple. Three different sections. The first one, we will be talking about the evolution of LLM. Second one, we'll be talking about how we are going to, how Apache Flink can be used and stream data into the AI applications. And in the third step, we'll be trying to showcase you the structure of the layout of how marrying both LLM and Apache Flink will be done. Okay, let's get started with the evolution of LLM. How did the idea of the AI started back when it was, because AI has been there for 50 years, right? But LLMs has started recently, right? Back when Google has written a paper in 2017 saying that attention is what all we need. But before that, there were several statistical models also which relied on just the rule-based, where the intuition is still less, right? So, but the main reason we wanted to achieve this LLM concept was we want to make sure the machines will try to depict and mimic the actions or the human behavior, right? So that's when this whole idea of LLMs came in, and that's when the statistical models went in. That's when we will be talking more, but this is all pre-ChatGPT era. Let's talk about how the post-ChatGPT era, let's listen from Ashish about that.
Yeah, so I'm not going for last 50 years. Let's take a scenario for last 3 years. 2022, there was an explosion with ChatGPT, and people get to know about what is LLM is all about. AI and ML guys are aware about LLMs and everything, but after ChatGPT, there was a spark everywhere, and everyone is using that LLM-based solution. In 2023, it's all about the experimentations. So many major players were coming up with their LLM solutions, like Microsoft, Ali Cloud. So many guys are there in the market, and they are coming up with their LLM-based solutions. While as a developer, we are doing some testing, POC, and developing a prototype for our enterprise customer. Now, in 2024, the current year is about the year of production. Enterprise customers has adopted LLM-based solution. It's running in the production environment, and now we have full-fledged solution for LLM-based solution. Enterprise customers also has their KPIs budget available for our LLM-based solution. As you can see in this slide, all the industry, whether it is banking, software, communication, media, traveling, video generation, everyone is using LLM-based solution. So what they are doing is they are having their data source in the form of text, image, audio, video. They are training their model. Model can be any LLM-based model. And they are developing the applications like content creation, Q&A chatbot. Then they have anomaly detection, risk management, and a number of applications are being developed for the enterprise-based customers. But as we know, like every positive has their own negatives as well. So let's hear about something like what are the negatives and challenges from Swaroop for LLM.
Thank you, Ashish. So there'll be a lot of to and fro, guys. Please bear with us. We wanted to make it more like a conversation, the whole interaction. So let's dive into what are the challenges we have currently in the LLM area, right? The first one would be the hallucination. The second one is verifiability. And the third one will be the knowledge cutoff. Because all the LLMs right now are being trained based on the existing data, right? And then they are not fed with the real-time inputs or the real-time data. So we would like to spotlight on these three. The first one, if you see in the example, I was asking the LLM, can you tell me the updates on Queen LLM? The first thing that it has, because the LLM was not trained on the latest data, it has hallucinated. Are you asking about the Queen Elizabeth? Or are you talking about the Queen Band? Or is it it started to hallucinate saying that, is it a fictional character? So this is one of the interesting challenge which we have found in the basic LLM. And also, the second one would be, which I was telling, since it didn't had the real-time data of when the elections happened, right? So I asked, do you know who won the US presidential election 2024? And apparently it said that it didn't know because it didn't have the data. Sometimes it will also say that the election itself didn't happen. So things like this happen. So these were a few challenges we wanted to, if you go to the next slide, please. So we wanted to focus on a solution that will actually help us in this kind of challenges. I think Ashish would be the right person to give an introduction on this. So yeah.
I think thanks to our previous speaker who has elaborated about RAG, Retrieval Augmented Generation. Now it will be easier for you. I won't go deep dive in this particular thing. Retrieval Augmented Generation is like you will be retrieve your document from your data sources. Enterprise customers may have their data. They will getting the data from there. We will pass it to LLM, and LLM will generate the response on the basis of that particular document. What are the benefits of it? We will be getting up-to-date data, accuracy will be there, it can reduce the hallucination, and it is one of the efficient and cost-effective solution as compared to other option that is available in the market. So there are two-step process, already mentioned by our previous speaker again. So it's like a data ingestion and storage, and second would be retrieval and generation. So let's do a little bit discussion on these two steps. Swaroop can give a better understanding about these two steps.
So the first one would be data ingestion, right? So this, which means you're trying to create a knowledge base of all the data that's available, or till what are the latest information data points you want the LLM to know, apart from the data which it has been trained on. The first step would be to collect the data. If you can, the knowledge source. It can be of any format. Like I'm sure everybody knows that we have PDFs, Excel, CSVs, or images also. And then how it works is the whole data is being chunked using text recursive splitter or any other splitters, and then those chunk using an embedding model, you will run into a floating point number, which is now called as vectors, and stored in the vector database. This is a concept which a machine can understand the relation between words or the position of the words irrespective of where it is in the sentence. That is what vector database is really useful for when you are extracting. So since now we have the knowledge base, right? What will be the application layer? How does it look when we are retrieving the data from the vector database? Initially, when the user asks a query, the app sends the query to the vector database using an embedding model to retrieve the chunk that are required or relevant to the question. So when the retrieved chunks is come to the application layer, the application sends both query and the retrieved chunk to the LLM to get the answer. And then since the LLMs right now are text generation based on both the data points, it tries to answer and then it never hallucinates because right now it has the context of just the query and the retrieved chunk. So that's when LLM answers back and the application layer displays out to the user based on that's the last step. And if you can go to the next slide, please.
I think after RAG, everything is resolved, right? All the answer will be resolved. So? Yeah, you can see like, okay. We have an application. I asked about to review the logs to find the anomaly for our application. And LLM is giving the answer because it has. Nice. Yeah. You can see the answers is here from our application logs. Okay. So I think the issue is resolved, right?
But have you ever tried asking for the latest data of the logs?
Latest data? Yeah. Let me try.
Okay.
Oh.
See, let's say 1 hour before.
Oh, it's not there.
So how?
I mean, do we really need real-time data?
We definitely need real-time data. That is the main agenda of this whole event, right? So that if we are sending batches of data and trying to store it in vector database, it's still outdated because it's not real-time data. So that is where we want to bring Apache Flink. The benefits of real-time data, if you go to the next slide, please, we have written few benefits where the user experience will be definitely improved if we use the real-time data because he'll be updated with the current happenings. And also the data is agile enough to understand that what's happening in the current state. So let's understand, now we understood the RAG architecture, right? So now comes the big boy in the room, right? Apache Flink. Let's try to listen from Ashish on Apache Flink.
So I think everyone is aware about Apache Flink in this room. So it's an open source framework driven by the community. It helps for the batch processing data as well as real-time data processing is there. It can handle a large amount of data. And of course, it will provide a low latency. So if you are not aware about Apache Flink, this is the best platform. This is the best event. You can have the tech talks later on as well for the Apache Flink, and you can go through it and learn more about Apache Flink. So I can show some features that is available for Apache Flink it's an open source framework. Why we need open source? Okay, as a developer, yes, I need open source to design my solution as per my requirement as well. Streaming data processing is there, real-time data processing is there. It's a fault tolerant. It also helps you to do the batch processing as well. It has a distributed system. It has the state for operations are there. And the most and important thing which may require for the real-time data processing, especially in the LLM, is low latency. So it has so many features out there, and we can utilize Apache Flink in our real-time LLM-based solution as well. So as you can see, the most important thing is here, like Apache Flink is something not only available in one of the provider. We have our, so many partners are available which are providing the Apache Flink. So most important thing is like seamless integration. So Apache Flink will be getting some data, and it will be sending some data to some other sink as well. So we can say like source and sink. So if you will see, there are so many providers available in terms of sending a data to Apache Flink. It has a seamless integration with so many providers that is available in our market. Then Apache Flink will do the processing, analyze the data, and it will send the data to our sink. And then you can see, again, all the number of partners or the service provider or the services are there where we can send our data to those kind of service providers as well, or the services, I would say. The next thing is, whenever we are developing an application, it's very important how we are going to deploy that solution. Okay, so people will say on-premise system, some will say managed cloud, and some will say, okay, we will utilize our third-party vendors. Apache Flink is having a feature that can be deployed in n number of solutions, whether it is Docker, Ali Cloud, any service provider, whether it is with the third-party vendors like Decodable or Verica, it can be deployed everywhere, and it provides the seamless end-to-end integration. So that's why Apache Flink is a key player when you are looking for a real-time data streaming-based solutions. So the last topic is implementation. That is quite important. How we are going to do this kind of implementation with Apache Flink and LLM. Before this, we have to see what are the components and the layouts are available to develop our LLM-based solution. So it would be like a high level. And we can see like we have our data sources available, data sources from IoT, application, mobile apps, and any other services as well. We will be having a Kafka. Then we have our Flink. Embedding model is available. It can be our open source or closed. As per your requirement, business requirement, we will be having vector databases where we are going to store the vector. And then LLM, any LLM is available. We are utilizing Quinn in this example. And there will be a user who will be asking so many queries, and it will be getting a response from them. So we can, I think, Swaroop, you can just tell more about the end-to-end solution, and maybe it will be useful for them as well.
Right. Now that we saw the components, what happens is this is how the flow or the architecture we wanted to implement for the streamlining the live real-time data. So the data source will be coming from different web data points, and then we'll be streaming it through Kafka, which will send the topics into the Apache Flink, where we, as we have heard from the previous talk, the async IO data inputs will be sent to the embedding model, and then they will be, we learned from the RAG architecture, right? The embedding model will be trying to send the data convert them into vector database. And the vector database will be continuously updated based on the real-time data. When a user actually asks for a question, it goes directly to the embedding model, and then the embedding model will retrieve the chunk and give the answer accordingly based on the query. It can be, in this case, we wanted to showcase the queen, and the queen will be answering the user based on the query that the user has implemented. Having said that, we actually thought that this is an interesting architecture we wanted to work on, but we thought let's also try to see the other side of the coin, and also talk about what are some of the considerations and challenges we'll be facing while implementing this. As the people from the open community, right? So we wanted to consider the latency because each module has different kinds of response time and inference levels. So based on that, we need to consider that and where we are trying to run these situations, instances. At the same time, when we are dealing with huge data sources, there is definitely a problem model complexity. And if you want to fine-tune it more to a particular set of instructions, then there will be definitely bias and modal overfitting issue. So that is one thing. And definitely everybody, as talking, is called, the ethical considerations are also important to take care, because the guardrails must be in place to make sure it's not going out of the context, or the real-time data is not misused in case of it. Having said that, I think we would like to end this presentation. And thank you so much for listening to us. That's our presentation.
Yeah, I think I would like to thank our organizers to giving us an opportunity in this platform to share about our use case that we have presented here, how to develop this LLM. I think Apache Flink is something that we are utilizing in most of the company, whether it is enterprise or small scale companies. Kudos to our organizers, everyone, and especially the community, because if the community will work, our solution will grow, and this will help us to solve our day-to-day problem, whether it is enterprise or any other industry. Yeah, so thanks a lot, guys. Yeah, that's
Thank
all.
you again.
Yeah.
Thank you so much.
Thank you, Ashish and also Swaroop, for the presentation of the future of real-time streaming of data to LLM.